Hello all, today we'll see the chi-square test method, which is basically used in statistics, and we are having its sign as x, capital X square. So first we should know what is the significance of chi-square test and why we are doing it exactly. We need to concern about our variables where we are working on. Here we are working on your variables. And when I'm talking about the variables, that should be my categorical values, where I can differentiate the values between discrete and categorical. For example, I can have a number of variables. For example, I would take one experiment where I need to toss a coin. So this is my experiment where I am working upon and I am tossing a coin. So if a situation is I'm having a head in both the signs, then a particular user is very well definite about its outcome. So if I'm tossing it 100 times, that means that I'm having 100 heads and I'm very much unsure about my definite outcome. But every time this is not the case. When tossing a coin, I'm having two options. One is head and another one is tail. So I take its value that it can be 50 times head and 50 times tail. So that means I'm not definite about my outcome value. Now, for example, I need to concern in this test about my observed value and my expected value. Now, what is the meaning of observed value and expected value? If I am tossing a coin 100 times, so I am saying that there can be chance or there can be the expected value of head is 50 or the tail is 50. But when I actually perform this experiment, the value will differ, and that value comes under the category of my observed value. Now, chi-square test basically is showing the dependency upon my O and E value, which I am signifying for my observed value and expected value. So, from this test, I can tell about any categorical value, or I can conclude the statement that how much variable is dependence. How much variable is dependent, or there is difference in O and E value. Now, we'll see directly one simple example. For example, I'm having a number of days, Sunday, Monday to Saturday. Now, we'll exactly see here the calculation part. And I'm saying that I'm having some observed value, that number of accidents per day, and I'm giving this random value as 12, 14, 15, 16, 19, 5 or 4. So this is my one of the example where given data is provided to you, where we are working on the variables of days, that is from Sunday to Saturday, and I'm having a number of accidents value. But that is my observed value. Now the question here is, what is my E value? Now, earlier I explained you an experiment where we are tossing a coin, and I am saying that my observed value for that tossing a coin for the head value is 50 and another value is my 40. That is my observed value when I am tossing a coin 100 times. But my expected value that I am taking it randomly, it can be my 70 and rest is my 30. So I have to find ultimately my chi-square value, and that includes your total calculations. Now what is that total calculation includes? For example, first I will calculate the value of O minus E. That is my observed value minus expected value. At the next step, I calculate my O minus E square value. That is, I am taking the square of observed minus expected. And then the third step, where my denominator will be the expected value with the numerator value as the square of O minus E. So chi-square, we get the value until and unless we solve this calculations value. These are the very important calculations for us. So that I can ultimately conclude my chi-square value is the summation of my O minus E ka square upon my E. That is, denominator will be your E value. And I have to sub the values of different experiments value. Now in this case, in the question, O value is given to you. But now my question to you is how I can find the E value. Now as we are not having any idea about E value, so I will find first its mean value. Why I am taking the mean? Because for expected value, I should know what is my final average value per day for the accidents. So my E value will be the summation of 12 plus 14 plus 15 plus 16, 19, 5 and 4, and denominator will be the total number of days where I am working upon. If I get this value as A, let its value after the calculation, I get the value as A. So this will becomes my E value for every case. So I can write here that my E value is A or for each and every day. So this concept should be very clear to all, because the observed value is given and my concern here is to find expected value. I can get this value until and unless I find the mu, because I have to take the average so that I can conclude this is my E value. Now as you get my E value, for each I apply all the formulas, that is O minus E chi square, and then to find final value for my chi square, I will get some value. For example, this is something like I am giving a random value like 3.14. This is my random value for chi square value. But the test is not completed yet here. I have to give some conclusion that how much my variable is having a dependency on my number of accident. So I have to take the two main conditions. What is this? Basically, I need to compare my chi square value with my critical value. Now what is a critical value? Actually, we are having one chi-square table which is already designed by our statisticians. They are having the value from 1 to 20. And this comes under we called it as degree of freedom. But what is its corresponding value is? Here we define the probability p-value. And for the probability value, I am considering my two columns. One is 0.05 and one is 0.01. Now, you come to know about how I am actually finding my chi-square value. But I am exactly comparing it with my critical value. Now, what is the meaning of degree of freedom? Degree of freedom basically tells about the product of your rows minus 1 and the columns minus 1. What it means here, if I am having more than 2 or 3 variables, I am having a combination of some matrix form where I need to consider my every combination with my rows and columns. So degree of freedom is defined by the product of R minus 1 into C minus 1. This is my degree of freedom that is already designed by statisticians from the value from 1 to 20. Now we come to the critical value. What is exactly a critical value? I'm having a two headings column, that is 0.05 and 0.01. This 0.05 and 0.01 is exactly signifying that in 0.05 I'm taking 95% my hypothesis will be in a right direction, or I can conclude that I can support or accept my hypothesis. Now what is exactly a hypothesis? What I'm initially taking the statement that is true statement and I'm proving that particular statement by chi-square test. 0.05 signifies that 95% I'm ensuring that concluding statement is my right, and 0.01% is saying 99% I'm concluding with the right decision, and 1% is a chance of my negative decision. And that 1% I'm not able to detect the factors. Factors means I'm not able to tell in a chi-square test what is exactly the factors is responsible for this much of deviation. Now we are having different critical values for each and every column. For example, we are starting with 3.14, 9.26 and everything. This is I'm taking the random value because this table is already designed by our statisticians. When I'm solving this particular problem for the chi-square test, I'm going to follow this only table for my critical values. These different values is called as a critical values. So the must concept in chi-square test is, once you are able to find the chi-square value, I need to compare it with my chi-square test table, where I'm having to concern about my degree of freedom and my p probability value. So what is the final conclusion in my statement is, I'm comparing my chi-square value with my critical value. So I can have an option, chi-square can be less than or equal to, and chi-square can be greater than a critical value. If this is the scenario, what I can conclude from these two conditions? I'm concluding from this condition is, if chi-square value which I calculated from an experiment and critical value from which the value is already given in the table, and if it's less than that, I'm saying there is no statistically difference between two distribution. Now what exactly means? I'm saying that whatever the two hypotheses you are considering for your calculation, there is no statistical difference. That I can also conclude. That means my observed result which I'm taking and which is already given in your question, they are not significantly different from my expected value. This is my conclusion from the condition, and that is where the chi-square test ends. I think that once the condition of chi-square is less than critical value is clear, we can directly conclude, if I get chi-square greater than critical value, then my condition for is there is a difference. There is a difference means there is a difference, that is my observed result are significantly different from expected result. And when I start this, I already told you that the purpose of chi-square test to determine the difference and the dependencies on your observed and my expected values. And the procedure for finding chi-square and comparing it with the critical value is little bit complicated, but in solving a chi-square value we just need to follow some formulas, and critical value I can get directly from my table for this two important comparisons. So here is the result for your chi-square test. This is basically used where we are using in statistics basically, and second to check out the dependency of the variables where we are working on categorical values. Thank you.